Hello, this is chapter 3, the second short video. Again, we're picking up with trying to find instantaneous rate of change, and the idea is that we're trying to find out at a particular day, like in this example would be day 3. But the problem is if we're finding out day 3, h would be 0. So what we're doing is we're taking the limit as h approaches 0. So let's look at that. So we're going to use technology to find out what happens on day 3. Now remember, on day 3, h would be 0, but if I plug in 0, our function would be undefined. So what we're going to do is we're going to plug in h values, getting closer and closer to 0. So you notice h is 1, then it's 0.1, then it's 0.01, then it's 0.001, then it's 0.00001, getting closer and closer to 0. So let's see what it approaches. Now it's really important that you understand what the formula is doing. So we're trying to find out day 3. We're going to find out a day later, 10th of a day later, 100th, 1000th, a 10,000th of a day later. So formula-wise, it's f of 3 plus 1 minus f of 3 over 1, a day later. Then we're going to plug in f of 3 plus 0.1 minus f of 3 divided by 0.1, 10th of a day later. F of 3 plus 0.01 minus f of 3 over 0.01, 100th of a day later. F of 3 plus 0.001 minus f of 3 over 0.001. That would be 10th, 100th, 1000th of a day. And then f of 3 plus 0.0001 minus f of 3 over 0.0001, which would be a 10,000th of a day. And this, again, we can do it in the calculator step by step like we did the other ones. Find out what f of 4 is minus f of 3 divided by 1, but the numbers are going to get really small after a while. So we're going to use some technology to do this. Okay, all the instructions are step by step here, so if you want to practice it, just follow along there or follow along with me. So I'm going to do this formula in the calculator. So we go to the calculator. Let's double check that we have the function in y1, 7500 plus 500x minus 100x squared. Then we're going to do second mode. Now, we're going to basically plug in all these formulas slowly in the calculator. So we're going to start with parenthesis, because we're going to put that entire top portion in parenthesis. And I'm going to do this first one here, this one f of 3 plus 1 minus f of 3 over 1. So I'm going to do the entire top in parenthesis. Again, all of your steps are here. We put the function in, second mode, then we're going to do this vars stuff. So I hit vars to the right for y vars, number 1 for function, and we're going to use y1 because that's where my function is. Parenthesis, we're going to plug in 3 plus 1, close parenthesis, minus vars to the right for y vars, number 1 for function, y1, parenthesis, 3, close parenthesis, close parenthesis. So remember with parentheses, if you open it, you got to close it, open it, close it, open it, close it, and then divided by 1. But before I move on, please understand, it's exactly like the formula here. I'm just doing it in my calculator. They match. So we're finding out what happens a day later. So when I plug in a day later, we get negative 200. Okay, now we're going to do the next formula. To save a little time, I'm going to push second, enter, and I'm going to insert by going to the 1, second, delete for insert, point. Make sure we change both of them, 0.1, so it matches the formula. Then we get negative 110. Second, enter. Now we're going to do insert, second, delete for insert, 0. Make sure we change both. Again, it matches the formula. Negative 101, second, enter, gives it back. We're going to insert, second, delete, 0. Second, delete, 0. That would be this one. And then second, enter, second, delete, 0, second, delete, 0, and again, they match, just doing it in the calculator. And what we're learning is, as we get closer and closer to 0, we notice what happens on day 3. It approaches about negative 100. So on day 3, the value is negative 100, so we can say on day 3, the average rate of change is decreasing 100 rupees per day. And again, all of your steps, practice, practice, practice. Okay, let's do another example. The air temperature in degrees Fahrenheit one spring morning was given by the function f of t equals 50 plus 0.1 t raised to the 4th t hours after 7 a.m. So 7 a.m. is 0, and then 4 hours later would be 11. We want to know how fast was the temperature rising at 9 a.m. So here's the idea. We know when we wake up in the morning, maybe it's cooler, and then throughout the day it gets warmer, it changes. I want to freeze time and find out what's happening at 9 a.m. Now 9 a.m. would be hour 2. So if 7 a.m. is 0, 9 a.m. would be hour 2. So notice we're going to go h of 1 hour later, 10th of an hour later, 100th of an hour, thousandths, and a 10,000ths. So all the work is here. F of 2 plus 1 minus f of 2 over 1. Then we plug in 0.1. Then we plug in 0.01, 0.001, 0.0001. Okay? So what's happening at 9 a.m., which is hour 2? So we're going to do as it approaches 0. So to do this in the calculator, again, we have a new function. So I go to y equals, clear the old one. The new function is 50. Again, make sure 50 plus 0.1 x, 0.1 x raised to the 4. So we have to change that, new problem, change that. Then we can go ahead and start plugging in these formulas. So I go to second mode, clear what I have. Remember, it starts with parenthesis, vars, vars, to the right for y vars. Choose number 1 for function, y1. The first one is 2 plus 1, close parenthesis, minus vars, y vars, function, y1, 2, close, divided by 2. And again, divided by 1. Remember, we're following the formula, I'm using the calculator just to save time, but we follow the formula. And we're going to repeat that. Second, enter, insert, point, make sure it's 0.1, second, enter, insert, repeat it, and the last one. Okay, that's where all the numbers come from. Now, you can see as it's approaching 0, we're approaching 3.2. So, at hour 2, what's happening? 3.2. So we can say at 9 a.m., which is hour 2, the average temperature is increasing 3.2 degrees Fahrenheit per hour. Okay? Now, as you're doing this over and over again, you're noticing these are nice, 1.1, 0.01, 0.001, but really the last one is one we care about. That's the one closest to 0, where you're correct. That's actually called the quick approximation. And the idea is that it's a quick estimate of 0. It's not 0, it's a quick estimate, So we'll do one last example. So again, here's a function. I'm trying to find out what happens at 1.5, but using the quick approximation. So we're using our formula to find the derivative as the h approaches 0, but we're doing the quick approximation. So we're going to do f of 1.5 plus 0.0001 minus f of 1.5 over 0.0001. So using 0.0001 instead of 0 is called a quick approximation. So first, write it out, show the formula, then we'll go to the calculator. I write out the calculator steps, that helps me. I'm going to go to the calculator, one last practice, clear out, go to y equals, we have a new function. Remember our function is x squared minus 4x. Go to second mode, parenthesis, vars, y vars, function, y1. And again, we wrote it all out so we can follow it. 1.5 plus 0.0001, close parenthesis, minus vars, y vars function parenthesis, oops, I'll choose y1 parenthesis 1.5 close parenthesis divided by 0.0001, and we get basically -1. Now it's not a word problem, so we can't explain because we don't have an input and output, but that's practice using quick approximation. So we're going to end with one last example. And my friend Eric, an enthusiastic baseball player, claims he can probably throw a baseball at an upward speed of 100 feet per second. Our physicist friend tells us that the input is time in seconds, the output is height. So we can take this function and graph it. So I go to my calculator, go to y equals, clear what's in there, 100x minus 16x squared. And our window, remember we're throwing a ball in the air. Let's say it will take somewhere between 0 and 8 seconds to hit the ground, counting by 1 second. And our height would be 0 to about 200 feet. 0 to 200 feet, counting by, let's say, 50s. And we can see that ball being thrown in the air and coming back down. So, as a review of everything we've learned so far, find the average velocity from 2 to 3 seconds. We're starting at 2, ending at 3, so a is 2. A second later, h would be 1, so f of 2 plus 1 is 3, f of 3 minus f of 2 over 1 second later. To find f of 3 and f of 2, we go to the calculator, go to the table, delete what we have in there, type in 3, 156, type in 2, 136. So 156 minus 136 is 20 over 1. So the average rate of change from 2 seconds to 3 seconds is increasing, positive 20 feet per second. And I can see that from 2 to 3 it's going up, and it's going up 20 feet per second. Now I want to find out what's happening at exactly 2 seconds using the quick approximation. So if we want to freeze time at 2 seconds, f of 2 plus 0.0001 minus f of 2 over 0.001. Let's see, we can do it in the calculator. There's all the steps. So if I went to the calculator, second mode, clear what I have, parenthesis, vars, y vars, function, y1, it would be 2 plus 0.0001, parenthesis, minus vars, function, y1, 2, close parenthesis, divided by 0.0001, and we get about 36. So we can say at 2 seconds, it's increasing 36 feet per second. If we froze time right there, that's what it would be. Thank you.